All right, we're going to start Chapter 7, Systems and Matrices. So 7.1 is Systems of Equations. So if you remember way back when, depending on when you went, where you went to school or whatever, linear systems are first degree polynomials. A set of equations is called a system, and a solution satisfies every equation. So when you have two lines, there can be one solution, the place where they cross. There can be no solutions if the lines are parallel, or there can be infinitely many solutions if they end up being the same line. When we have no solution, the set is the null set, and we can call it inconsistent or independent. When we have infinitely many solutions, those are consistent and dependent because they're the same line. There are various ways to solve systems. You can plug them into your calculator and see where they intersect, or we can do substitution. So substitution, you want to solve one of your equations so that it says y equals or x equals. So by doing this, I have now turned equation 2 into y equals 3 plus x. Now we're going to substitute that into our original equation. So by substitute, I mean we're going to take this and write it instead of the y. So instead of 2y, I'm writing 2 times 3 plus x. Now I'm going to distribute. Combine like terms. Bring the 6 to the other side. Divide by 5, and we get x equals 1. So if x equals 1, now we need to know the y coordinate. So I'm going to plug it back in here. So I get 3 plus 1, y equals 4. We can plug those into the original, one of the original equations to test. So 3 times 1 is 3, 2 times 4 is 8, and 3 plus 8 is 11. So it works, meaning our solution set is the point 1, 4. Elimination is when we multiply the equations by coefficients to get one of the variables to eliminate. So if we multiply the top equation by the coefficient of x in the other equation, we get 6x minus 8y equals 2. Then if we do the same thing to the bottom, but we multiply by the x coefficient of the top, we get 6x plus 9y equals 36. Now, when we get to this point, we want to eliminate the x's. So to be able to do that, we're going to say, well, they have the same sign, so we have to subtract the equations. So 6x minus 6x is 0. Negative 8y minus 9y is negative 17y. And 2 minus 36 is negative 34. So the same sign subtract. That means if the variable we're eliminating has the same sign, we subtract everything. Otherwise, we add everything. Now we divide both sides by negative 17, and we get y equals 2. Just like with substitution, the next step's the same. We're going to substitute that value of y in here and then solve for x. So 3x minus 8 equals 1. Add 8 to both sides, you get 3x equals 9. Divide by 3, you get x equals 3. And if we check this bottom equation, 2 times 3 is 6, 3 times 2 is 6, and 6 plus 6 is 12. So it works, and our solution set is the point 3, 2. So with elimination, you don't always have to multiply both equations. This top one, we could multiply this by 6 and this by 3 and deal with larger numbers. We also could say, hey, 3 times 2 is 6, so I really only need to multiply the top. 6x minus 4y equals 8. Bring this one over. Now, here's an example of where the variable we're eliminating are opposite. So we're going to add everything. 6 plus -6 is 0. -4 plus 4 is 0. And 8 plus 7 is 15. 0 never equals 15. So our solution set would be the null set. And these are inconsistent and independent lines. It means they're parallel and they'll never cross. Here's another example. This one, we could choose to do elimination or substitution. It's completely up to you. I'm going to do elimination. First one's going to carry over. Actually, I'll do both. So we'll do elimination over here, and I'll do substitution over there. Then if I distribute here, I get that. Different signs, so we're going to add everything. We get 0 equals 0. This is always true. So we have infinitely many solutions and a consistent or dependent system. Wow. Dependent system. Now, let's say I did substitution. So I added 4x to both sides. Y equals 2 plus 4x. And then I'm going to substitute that in the top equation. Distribute. We get 8x minus 4 minus 8x equals -4. Combine like terms. We get -4 equals -4, which is also always true. So it doesn't matter which way you do it, you get the same answer. Non-linear system has at least one of the equations that's not a line. So you could have a circle, you could have a parabola, you could have a cubic function. At least one of them is not a line. You solve them in the same ways, substitution or elimination. So here's one with a quadratic. Now, if I can avoid squaring binomials, I am going to try. So here I'm actually going to solve for y, even though it's a couple more steps, because it'll save me steps later on. Divide everything by 3. Y equals -4 minus x over 3. So now we can substitute that into the original equation. 3x squared. And then instead of y, -4 minus x over 3 equals 5. If I multiply everything by 3, actually, first I'm going to distribute. Let's just get rid of these parentheses. So -2 times -4 is +8. And -2 times -x is +2x. And if I put those over 3, because of this 3 here, we have that equation. Now I'm going to multiply everything by 3 because I want to cancel out the fractions. So 3 times 3x squared is 9x squared. 3 times 8 is 24, divided by 3 is 8. And 3 times 2x is 6x, divided by 3 is 2x. And I forgot. And then 3 times 5 is 15. Now I have a quadratic, so I want to subtract the 15x from both sides. So I get 9x squared plus 2x minus 7. We can tic-tac-toe this. So we have 9, 2, -63. 9, -7. 1, 9, 1, -7. So we have 9x minus 7, and we have x plus 1 equals 0. So if I solve those, I have x equals 7/9 and x equals -1. So we have two x values. So we actually have to solve this twice. We have to solve it once when y is 7/9, and we have to solve it once when y is -1. So if we put this in the calculator, we end up with -43 over 27. We put this in the calculator, we end up with -1. So that makes our solutions 7/9, comma, 43/27, and -1, -1. So let's see if that makes sense. We have a parabola and a line. They can cross in two places, so it makes sense that we'd have two spots. Here is another system. We have a circle and a line. So let's see what we can do. I am going to add y to both sides. So we get x equals 2 plus y. And then I'm going to substitute. So 2 plus y squared equals 4. Here, because they were both squared, there's no way to not have a binomial. So 2 squared is 4, 2y, and then you'd have 2y again, and then you'd have y squared. So combine like terms, you have 4, and you have 2y plus 2y is 4y, and y squared plus y squared is 2y squared. If you subtract 4 from both sides, you have 4y plus 2y squared equals 0. Now we could tic-tac-toe or say, hey, we have a greatest common factor. So I can take out 2y, and I'm left with 2 plus y equals 0. So this term is going to make y equals 0. And this term's going to make y equals -2. So we're going to plug those in. So if I plug it in here, x equals 2 plus 0, which means x equals 2. So one of our points is 2, 0. And then x equals 2 plus -2, x equals 0. So the other point is going to be -2, 0. That's where they intersect. So if we looked at this, we had a circle and a line, so they intersect in 2 points. That makes sense. All right. Sometimes graphing is the best way to solve a nonlinear system. So if we have an exponential function, we can put the first equation in y1 and the second equation in y2. So if that's our equation, we need it to say y equals. So I'm going to add y to both sides. And I get y equals absolute value of x plus 2. So if we graph this, the red is our absolute value. The other one is our 2 to the x. So we know we see one intersection point here. That's going to be this 2, 4. And then if we zoom in, there's actually 2 intersection points down here. So by using our second trace intersect, or finding the gray points on Desmos, you get the other 2. So this one actually had 3 intersection points. So 3 solutions. Application problems. The biggest things, read your problems, write your system, solve them, and then just check and see if it makes sense. That's always a good idea with word problems. Number of text messages sent per month by smartphone users vary by age. In a recent survey, the average number of texts sent by 2 age groups was 1,134. However, the number of texts sent by the 18 to 24-year-old age group exceeded the other one by 1,776. Determine how many texts were in each group. So average, so let's say our 18 to 24, that's going to be our X, and our 55 plus will be our Y. It's always good to define your X and Y. So the average, if we add them together and divide by 2, we got 1,134. So if you multiply both sides by 2, you get X plus Y equals 2,268. That's one equation. We also know that group X sent more, and when you subtract them, because they exceeded, it's by 1,776. So there's our second equation. So now let's solve those. we had x plus y equals 2,268. X minus y, because that was the difference in them. And now we can same side subtract. So we end up with 2y equals 4,044. Hold on. 2x, same side. Hold on. Oh, so what am I doing here? X plus x, we're adding. X plus x is 2x. Y plus negative y cancels out. Add those up. We get 4,044. Divide both sides by 2. The 18 to 15-year-olds sent 2,022. If we plug that in, 2,022 plus y equals 2,268. We end up with y equals 246. 246. So that gives us 18-year-olds were 2,022. 55 plus was 246. Now I'm just going to show you. You get the same answer if we solve for y instead. So if we subtracted, x minus x is 0. Y minus negative y is 2y. And 2,268 minus 1,776 is 492. Divide by 2, and you get 246. So it doesn't matter whether you solve for the x or the y, you'll get the same answer. Volume. So you have a box with an open top, square base, so all 4 of these sides are the same, then a height of y. The volume is 75 cubic inches, and the surface area is 85 square inches. So let's start by making our equation. Well, the volume is length times width times height, so that would be 75 is our volume. So 75 is going to equal x times y, which is the same as saying 75 equals x squared y. Surface area, well, we have this piece here, which would be x times y, and that's the same for all 4 of these. So we have 4 of those, and then it's open, so the bottom is this one, which is x times x, so x squared. So that equals 85. So our surface area equation was 4xy plus x squared. So now we have those 2 equations. So let's solve the first one for y. So 75 equals x squared y. Divide both sides by x squared. 75 over x squared equals y. So we'll plug that in here. 4x times 75 over x squared plus x squared. If we multiply that out, 4 times 75 is 300 x over x squared. Well, these x's, if we have an x on top, we can cancel 1 on the bottom. And now we're going to multiply everything by x to get rid of that fraction. So we have 85x equals 300 plus x cubed. And if I solve that for 0, 0 equals x cubed minus 85x plus 300. So we're going to graph this and see where it equals 0. So to do that, on a graphing calculator, we would type, what was it? X cubed minus 85x plus 300, graph. So if we zoom out, we can see there's 3 solutions, but this solution over here on the left is negative. You can't have negative length, so it's these 2 solutions that we're looking for. So second trace 0. We want our x-intercepts. So, see if I can find the spider here. Okay, there's that. There we go. So this one is 5.38. And then if we did the same thing, we'd get the other one over here, which is about 5.64. I don't like this calculator as much as my handheld one. And if you did Desmos, you would just have those as little gray dots. So that's how you could find the two solutions to this equation. So your x would be, all right, what did we say it was? 5 point, I lost myself here. Second trace 0. Second trace 0. So 0 and 30. Why is it doing this? Second trace 0. Y equals graph. Second trace 0. Left bound, right bound. So this one's 5.14. I'm going to write that down somewhere. Oh, I can write it down right here. 5.14. And if I go back to my graphing calculator, the other one, second trace 0, left bound, right bound, is 6.09. Here we go, 6.09. So now we would plug those in for x. So if I did 5.14 to the third minus 85 times 5.14 plus 300, I get one of our y values. As negative 1.1. And if I do the same thing with 6.09, I get 8.2. So those are our two y values, meaning our coordinates, where these two pieces are going to intersect, would be this. So there we have that one. All right. So this is just showing us the same thing. It has our equation, where those two answers are. They got something a little different than I did. But that could be because I typed something wrong on the calculator. Yeah, who knows? I don't understand my calculator sometimes. So anyway, those would be the answers. That's how you do it. Plug those in for y and get your other answers. So I'm going to try this on my handheld calculator. Window, Zoom 6. Okay, second calc 0. Come on. Yeah, so that one I got 5. So when I did it on my handheld calculator instead of this one, I got the 5 that they got. And 5.64. So something went wrong on this calculator, but it's the same idea. So that is 7.1. Let me know if you have any questions.